Good morning or good afternoon, depending on when you are listening to this. And welcome to Chapter 1 of AP Stat. We are going to be looking at the basics of data analysis in this chapter. And we're going to start by doing a little introduction about what is data analysis. Oh, would you look at that? Mr. Vita is calling me right now. I'm going to call him back in. Okay. Let's talk about what statistics is. Statistics is the science of data. It really is a science more than it is a math. And data analysis, which is what we're going to be doing, is the process of organizing, displaying, summarizing, and asking questions about data. So our task today is to figure out how to organize and display data, and then we'll eventually get to how we can summarize it and eventually ask and answer questions about what our data means to us. In data analysis, you have individuals and you have a variable. The individuals are the objects described by a set of data, and the variable is the characteristic of the individual. This chapter focuses on two types of variables. We have categorical variables and we have quantitative variables. Categorical variables place an individual into a group or a category, such as your favorite pizza, or the color of your eyes, or the color of your hair, or your favorite car. Quantitative variables is when your individual takes a numerical value, such as your height or your weight. Those are numerical values, and those are quantitative variables. And anything that makes sense to take an average of or find the mean can be defined as a quantitative variable. So a variable generally takes on many different values. We're often interested in how often a variable takes on each value. We're going to find a way to take our data and make a distribution. Distributions tells us what values a variable takes and how often it takes those values. And there are various types of distribution that we're going to learn. Histograms, there are dot plots. For example, they took this data here, which is the miles per gallon that a car gets. So our variable of interest is miles per gallon. That is a quantitative variable. And we can take this and turn it into a distribution called a dot plot. This is one way to organize quantitative data. So this is a pictorial expression of the data that you see about the miles per gallon. How to explore data. Okay, so we can examine each variable by itself and study the relationships among the variables. So if I'm giving you data, the first thing you should want to do is put it into some sort of picture, right? A graph. Here I put it into a dot plot. You might eventually want to put it into a histogram. If you have categorical variables, you want to use something else. And we'll talk more about that later. This is just an introduction. So you want to take your data and put it into some sort of graph, a picture, okay? Then you want to put some numerical summaries, whether it's a 5-number summary or the mean standard deviation. That's the beginning of exploring data. Ultimately, our class and what data analysis is all about is we have this very large population, and we can't ask every single person a question in the population. For example, if I want to know the average height of everyone in America, I'm not going to go around asking 300 million people what their height is, because that is just not feasible. So what we do is we take a sample from the population, okay? And we collect data from that sample. Because we can collect data from 300 people, that is a lot easier than doing 300 million people. If we collect data respectfully and collect data correctly, we can then perform data analysis, which we'll talk about. And then we can use our data analysis to make an inference about the population. So as long as our sample is representative of the population, then our sample data should be pretty close to what the population data would say. Okay, so this is the ultimate goal. Now, we won't get into inference testing and making inferences until later this year. But we're going to start by collecting and performing data analysis. Okay. Starting with our first type of variable, categorical variable and categorical data. What is categorical data? Well, categorical variables place individuals into one of several groups or categories. Here is an example of type of number of stations, that are play this type of music. Okay, so we have country, news, talk, oldies, things like that, and this is the counts. So our variable is the type of music or the format of the music. Okay, that's our variable. The values are the physical types of music. So, oldies, religious, rock, Spanish language, those are the actual values. These are the counts. They tell you how many, how many objects, in this case, how many stations are in each different category. And then another way to look at categorical variables is using percentages. So you'll see on the right side, all of the percents. So while counts are useful, when we're looking at categorical variables, it's often very useful, even more useful, to use percentages. Now you'll notice at the bottom, the total is 99.9%. And many students are always confused, why is it not 100%? Oftentimes it's just a small rounding error with the way that it is rounded only to one decimal. And that's why it adds up to 99.9, which is not a huge deal. Okay. So how can we organize categorical data, right? Our job was, the first thing we do is we get data and then we put it into some type of picture. And the last picture we looked at was what was called a dot plot. But that's for quantitative variables. So we're not there yet. Right now I want to look at just categorical variables and categorical data. So one thing we could do, if we have a frequency table or counts, frequency and counts are the same thing, then we can put it into a pie graph. So we could turn this right into a pie graph where my x-axis is just the various categories and my y-axis is counts. Okay. Notice that my bar graph has a title. It has an x-axis labeled and a y-axis labeled. Okay, if you are going to draw me a bar graph, which you will be drawing bar graphs, you need to make sure your bar graph has a title, it has labels on both the x and y axis, and it is roughly scaled. If we're talking about relative frequency or percents, you can look at my relative frequency table, and one way to display relative frequency for a categorical variable is using a pie chart. And here is the pie chart. And you'll see in very small writing that the pie chart has all of its labels and its colors there for you. Okay, so bar graphs and pie charts are great ways to display categorical variables, depending on if you're using frequency or relative frequency. So when you're drawing a bar graph, I told you already you need an x and y axis and a title. Make sure your bars are equally wide, because your eyes react to the area of the bars as well as the height. So make sure that they are the same width, so that you're not fooling the eyes when you're looking at the bar graph. Don't use a pictograph. Pictographs are bad because they really disjoint the graph because of the pictures and how the pictures could represent different sizes. For example, if for one category you're talking about apples and you draw an apple, another category you're talking about trucks and you draw a truck, the apple and the truck could be different sizes. So therefore, you don't want to be drawing apples and trucks. You want to be drawing bars, and make sure bars are equally wide. And make sure your scales are are consistent throughout. So don't jump from 100 to 500 to 550. Make sure you have equal jumps in your scaling. Sometimes we want to look at a data set that involves two categorical variables. And when we do this, we can analyze what's called a two-way table. So a two-way table describes two categorical variables and organizes counts according to a row variable and a column variable. So I have a row and a column. Each of them will represent one of my two categorical variables. For example, here is young adults by gender and chance of getting rich. So the two variables are gender, right? Gender, and then whether they think their chances of getting rich are. If you were asking me, my chances of getting rich, I would be right here. Almost no chance. I am a teacher, and I have accepted the fact that I will never be rich. That's okay. I enjoy what I do for a living. Okay, so those are my two categorical variables: their chance of getting rich and gender. Okay. The marginal distribution of one of the categorical variables in a two-way table of counts is the distribution of values of that variable among all individuals described by the table. Oftentimes, like I said before, percents are more informative than counts, especially when comparing groups of different sizes. So now that we're looking at two different categorical variables, we're looking at groups of different sizes. So instead of looking at counts, we want to look at percents. And marginal distributions can help us look at percents. So when we're examining a marginal distribution, we're going to use the data in the table to calculate the marginal distributions in percents of the row or column, depending on what the question is asking us to do. Okay. And then the next thing you want to do, just like you do with any data set, is to make a graph with that marginal distribution. Let's do an example. So it says examine the marginal distribution of chance of getting rich. So the variable we're looking at is chance of getting rich. So what percent of students or people said that they have almost no chance of getting rich? Well, there are 194 combined female and male students who said they have almost no chance of getting rich. Divided by 48.26 gives me 4% of the people saying that there was almost no chance of getting rich. And we can do that for every single category or outcome in this categorical variable. And the variable is chance of getting rich. Okay, so we look at each marginal distribution. And this allows us to analyze it. Now, instead of looking at just counts, I can say, okay, most people thought there was either a 50-50 chance or a good chance, right? There's almost 60% of the people are in this area. Okay. Then I want to take these outcomes and put them into a graph. Here's my bar graph. You can put them into any graph you would like. You could have done a pie chart if you wanted to, but here I did a bar graph, and you'll see my x-axis is the survey response, and the y-axis is now percents. So our y-axis is no longer counts. So that's why it's very important to label the x and y-axis in the context of the problem. Now, some of you might say, hey, Mr. Walsh or Mr. Vita, there is no title to this bar graph. There is. It's just behind this survey or this table here. Okay. A conditional distribution of a variable describes the value of the variable among individuals who have a specific value of another variable. What? Okay, well, conditional distribution is like conditional probability, right? We're looking at a specific condition. So how to examine and compare conditional distributions? First, we want to select a row or column of interest, depending on what conditional variable we're looking at. It says use the data in the table to calculate the conditional distribution. Again, percents are always better when comparing different size groups. Then, of course, we want to make a graph to display the conditional distribution. So let's look at an example. to calculate the conditional distribution of opinion among males. Then examine the relationship between gender and opinion. So I want to look at the conditional distribution about males and then the conditional distribution among females, and I want to compare males to females. So now, if I'm looking at just males, now I want to figure out how many males thought there was almost no chance, and how many males thought there was some chance, but probably not, and so forth. So now my 98 is not divided by the total, it's divided by just the total number of males. So 98 over 2459 gives you 4% of males said almost no chance. And I could do that for each outcome in my categorical variable about the possibility of getting rich. And I can compare that with the females. So I can do the same thing with the females. 96 divided by 2367, that gives you 4.1%. And now I can put these in either a side-by-side bar graph or a segmented bar graph. We chose a segmented bar graph, and here's what we got. Right, here are the males on the one on the left, and then the females are the segmented bar graph on the right. And just by looking at this, I want to try to make some sort of generalization, maybe a rough conclusion, just so based on what I see. And what I see is that looks like males think that are more confident in their ability to get rich. Because if you look at the red, which is a good chance, and the purple, which is almost certain, that those two together are bigger than the females. A lot of the females seem to be in the 50-50 range, which is in here. Okay. Can we say there is association between gender and opinion in the population of young adults? Well, that was a question I kind of just answered, right? I looked at the graph and I was trying to talk about the association between gender and the opinion in population of young adults. However, we can't make any strong conclusions. I can make generalizations. Like I can say, okay, like I think this is happening, but we have no proof. This is just the very first step of data analysis. In later chapters, we're gonna do what's called inference testing, and that's how we make inferences on larger populations. This is just organizing the data that we have collected. Once my data is organized, I can talk about it. I can start asking questions, but I can't make any conclusions until I do a formal inference test, which is what this is saying here. Making this determination requires formal inference, which we're going to wait a few chapters to do. Okay? The reason why we need a formal inference test is because even a strong association between two categorical variables can be influenced by other lurking variables in the background. Lurking variables. This is the example I love to give every year. Okay? And you're going to tell me, you're going to think about what kind of lurking variable might be in the background. And the statement is the sales of ice cream increase at the same time that the number of shark attacks increase. Does that mean that ice cream sales are causing shark attacks? Right? There's a strong association between the number of ice creams that are sold and the number of shark attacks that occur. So does that mean that ice cream sales are causing shark attacks? And obviously the answer is no. Buying ice cream does not cause someone to get eaten by a shark. The lurking variable there is that people buy ice cream in the summer and shark attacks happen in the summer because people are at the beach in the water where sharks live. Okay? So just because there is a strong association doesn't mean that there is a causation. Right? There are other things that could be lurking in the background. That's why we have to do a formal inference test to make any sort of strong conclusions about the data that we're looking at. So today we're collecting and organizing our categorical variables. Next time we will look at quantitative variables. I'll see you all soon.